For months, the global astronomy community had been tracking an obscure interstellar visitor they initially dismissed as a routine cometon object catalogued as 3I Atlas, a name that barely attracted attention outside observatory circles. But everything changed on the morning of November 9th, when two observatories, operating independently, released images that would ripple across the scientific world like an electric shock. The James Webb Space Telescope delivered its high-resolution infrared snapshots at nearly the same moment the Virtual Telescope Project published their optical frame sequence, and what both instruments saw was nothing short of heresy to physics. Instead of the diffuse halo, the ragged fan of vapor, and the dusty plume that should surround any comet diving toward the sun, Atlas appeared as a solitary spark-sharp edged, clean, perfectly compact, as if carved rather than formed. Even stranger, the new images looked unbearably similar to those captured 4 months earlier by Hubble. No erosion, no shedding of mass, no discoloration. For an object bathing in a furnace of solar radiation, it was an insult to the very idea of thermal physics. In a single weekend, Atlas went from an unremarkable dot on astronomers' spreadsheets to the most scrutinized visitor our solar system has seen since the enigmatic Oumuamua. The first warnings arrived quietly. Observatory logs from late October showed a collection of anomalies that were so statistically improbable that analysts initially blamed software updates or calibration errors. When recalculated manually, however, they remained stubbornly real. As Atlas approached perihelion, its closest point to the sun, it sped up. Everything in orbit slows when approaching a star due to drag from solar radiation and sublimation losses, but Atlas behaved as if it had ignited a hidden engine. Calculations from NASA's Jet Propulsion Laboratory revealed a shift in position amounting to tens of thousands of kilometers, all triggered by an acceleration too subtle for human eyes, yet too deliberate to be random. What made the anomaly terrifying wasn't the magnitude, but the direction. The object accelerated away from the sun and drifted sideways with uncanny smoothness, as if following a trajectory mapped by an intelligence rather than by nature. When astronomers calculated how much outgassing would have been required to generate such thrust, the answer arrived like a punch to the chest: more than 5 billion tons of material would have had to be expelled. But telescopes large and small saw the same thing every night: a silent pinprick of blue light with no halo, no jet, and no debris. It was the celestial equivalent of watching a rocket soar without exhaust. The Virtual Telescope Project highlighted the absurdity by releasing a comparison: Atlas versus Comet Leonard, photographed under identical settings. Leonard displayed the classic luminous plume every student of astronomy expects. Atlas remained a surgical point of light, untouched, almost arrogant in its clarity. Researchers described the contrast as the difference between a breathing creature and a marble statue, one full of life, the other frozen in defiance of natural law. Behind closed doors, astrophysicists whispered theories they were afraid to say aloud. When Avi Loeb, a controversial but respected voice in cosmic anomalies, reviewed the data, he called the object a cosmic challenge, a subtle phrase hinting at possibilities he hesitated to articulate. By the first week of November, a global network of observatories from Mauna Kea in Hawaii to Atacama in Chile was feeding nonstop data into supercomputers that recalculated Atlas's trajectory every hour. A grim pattern emerged: every variable that defined the object was wrong. Mass too large, movement too precise, brightness too stable, color too unnatural. And above all, a heat signature that looked engineered, not evaporated. More alarming still was the orbit. Most interstellar objects arrive tilted at extreme angles relative to the solar system's plane, like stones skipping across a pond. Atlas, however, approached almost perfectly aligned with the ecliptic, within mere degrees of the orbital path shared by Earth and its neighboring planets. Statistically, this was nearly impossibly as if something had intentionally aimed it through the solar system's busiest highway. And then came the jet anomaly. Sensitive infrared scanners recorded a narrow burst of material that, unlike any comet ever studied, was fired toward the sun, not away from it. To scientists, this was the astrophysical equivalent of throwing water uphill. Solar radiation should push dust outward, not inward. The only way to produce a sunward jet was through a mechanism that fought against solar force. Nature does not do that. Machines do. Spectroscopy intensified the mystery. Light reflected from Atlas showed highly ordered polarization, with wavelengths aligned so neatly that even the most polished asteroid or icy body could never mimic it. Some kind of smooth, resilient surface was shaping the light, not an irregular crust of rock and ice, but something symmetrical, like plating or composite shielding. The object also reflected an electric blue hue associated with extremely high temperatures, hotter than the sun's own surface, yet it remained perfectly intact, showing no melting, darkening, or fragmentation. A comet operating at those conditions should have been torn apart in hours. But Atlas held firm, like a vessel designed to endure it. When chemical analysis revealed a refined nickel-iron composition matching advanced aerospace alloys rather than natural meteorite blends, doubts evaporated. This wasn't a dirty snowball at all. It was something crafted, precise, purposeful, and as more data accumulated, the implications grew heavier. Atlas wasn't merely defying physics, it was following instructions. By mid-November, the scientific community had split into two camps, those clinging to familiar physics and those reluctantly stepping into the realm of the extraordinary. What terrified both sides equally was the emerging trajectory map. When plotted over a span of 6 months, Atlas traced a serpentine path through the inner solar system that brought it into proximity with Mars, Venus, and Jupiter, skimming their orbital lanes with pinpoint accuracy but never once drifting toward Earth. It was as if the object were inspecting the solar system through a series of calculated flybys, avoiding our planet with deliberate precision. Even the skeptics admitted that such an alignment was uncanny. Space is vast. Planets occupy minuscule slices of their orbits. For a foreign interstellar body to thread itself through these regions by coincidence bordered on impossible. To some analysts, it looked like reconnaissance. To others, a test. And to the most cautious scientists, it resembled a long-term automated mission designed by a civilization long vanished, its instructions still operating flawlessly eons after its makers were gone. What troubled researchers even more was the nature of the acceleration itself. Unlike the chaotic wobbles produced by melting ice or uneven mass distribution, Atlas's thrust curve was smooth, mathematically smooth, like the output of a regulated propulsion system. Simulations revealed that the motion aligned itself with the angle of incoming solar radiation, adjusting minutely in response to the sun's changing position, almost as if the object were harnessing light deliberately, reorienting itself like a sail that absorbed photons instead of wind. But this solar sail hypothesis fell apart when analysts considered its mass. At more than 30 billion tons, Atlas was a mountain of metal, far too heavy for sunlight to maneuver in any meaningful way. The only possibility left was an internal energy source, something compact, potent, and completely unknown to current physics. No engine exhaust, no thermal plume, no detectable emissions at all. Whatever propelled Atlas did so invisibly, efficiently, and silently. While governments debated how much of the data to release to the public, scientists confronted the reality that this object violated every known rule of celestial mechanics. Its brightness curve wasn't just unusual, it was antagonistic to natural interpretation. As Atlas drew closer to the sun, instead of shedding material and dimming, it grew brighter at a rate double that of the most reactive comets ever observed. Its blue coloration intensified, pulsing with a cold luminosity that did not fluctuate with solar activity. Instruments able to capture spectral details found that its surface emitted almost no chaotic scattering. It was reflecting light like a flawless engineered surface, not like a porous natural body. Researchers proposed theories ranging from high-temperature ceramics to unknown composites capable of surviving plasma-level heat. In all models, one detail kept resurfacing. The object looked finished, as though manufactured, not accumulated by slow cosmic processes. The deeper scientists delved into its composition, the more unsettling the results became. The nickel-iron ratio inside Atlas was so precise and so balanced that metallurgists joked it looked like aerospace-grade alloying. Natural metal mixtures tend to be messy, polluted with unexpected minerals and random impurities. Atlas, on the other hand, reflected refinement-controlled proportions, structural uniformity, and minute trace elements that suggested exposure to intense manufacturing heat. Even more puzzling was its water content, less than 4%. For a supposed comet, this was laughably low. It wasn't a melting snowball. It was a monolithic structure wrapped in something hard, dark, and unyielding. And when polarization data revealed that the reflected light followed a mathematically perfect pattern, something never once recorded from any asteroid or comet, speculation transformed into alarm. A natural body simply cannot polarize light with such discipline. But an engineered surface can. Investigators revisiting the motion logs noticed an even more chilling detail. Atlas was adjusting itself. Tiny course corrections occurred at intervals too regular to be coincidental. Each slight shift compensated for gravitational pulls from nearby planets, as though maintaining a long-planned route. These adjustments were not large enough to indicate steering toward a specific destination, but they were precise enough to imply awareness of orbital mechanics. If Atlas was an ancient probe, its navigation system was not only functioning, it was astronomically advanced. Observatories in Europe reported faint fluctuations in the object's rotational speed, not random but systematic, as if a stabilization mechanism were intermittently functioning. While no electromagnetic signals were detected, a few fringe researchers proposed that Atlas might use a form of communication or sensing technology that our equipment cannot register, something beyond radio, microwave, or optical ranges. Despite mounting evidence, the public remained unaware of the most dramatic revelation. The object's path, after passing Jupiter's orbital lane, would lead it cleanly out of the solar system again. It was not stopping. It was not approaching Earth. It was traveling through our celestial neighborhood like a tourist following a map. making pre-selected flybys before departing toward another star entirely. The implications were staggering. If it was a probe, then its creators did not design it to contact emerging civilizations. It might simply be collecting samples, measuring fields, or scanning planetary atmospheres. It may have been launched millions of years before humanity even existed. Its intent, if any, remained inscrutable. By the second week of November, a consensus began forming among quietly frantic scientists. Atlas was not behaving like a comet, asteroid, or fragment of interstellar debris. It was behaving like a technological artifact, a machine finishing an ancient route, indifferent to the life blooming on one small blue planet nearby. Some argued it might be derelict, operating on automated instructions long after its creators were gone. Others speculated it might be a test of endurance, a probe built to survive cosmic radiation, stellar heat, and the corrosive dust of galactic travel for billions of years. And a few, though reluctant, entertained the rarest possibility of all that Atlas was not merely passing through, but performing a survey of solar systems aligned with habitable zones. If that were true, then Earth's exclusion from its trajectory was not comforting. It was intentional. As 3I Atlas continued its ascent away from the sun, its blue shimmer pulsed like an unblinking beacon against the void, neither threatening nor welcoming, simply performing its mission with silent precision. Humanity could only watch, humbled and bewildered. As the most advanced telescopes ever built pointed toward a mystery older than civilization itself, an object that followed no natural rule, answered no human question, and left behind a single chilling conclusion. As we move closer to December 19th, the night sky feels less like an expanse of stars and more like a stage constructed around a single spotlight, one that refuses to dim or disclose its purpose. 3I Atlas continues its silent journey through the solar system, defying every prediction that classic astrophysics tried to chain around it. If it were a comet, the sun should have torn it apart by now. Instead, Atlas shines with the serene composure of something built to endure. If it were an asteroid, its reflectivity would shift, its color would scatter, its surface would betray some fracture or irregularity. Instead, the object rotates with a symmetry so precise it borders on mechanical. And if it were space debris from some forgotten cosmic collision, then why does every spectroscopic reading hint at refined metal ratios, hit-resistant composites, and surface textures that resemble engineered alloys more than primordial rock? The closer humanity looks, the more the object behaves as if it wants us to see only what it chooses. Its ultraviolet glow remains unchanging, unaffected by proximity to the sun. Its trajectory remains impossibly stable, as though guided by a navigation system that updates in real time. Its approach vector remains angled away from Earth, avoiding a direct path with such precision that even small gravitational perturbations seem corrected, cancelled, resisted. Rumors spread quietly among analysts, rumors that Atlas had adjusted its motion subtly whenever observational windows improved, shifting its position just enough to frustrate deep field scans, but never enough to trigger public alarm. It was like trying to photograph a cat that always steps out of frame the second the shutter clicks. Yet Atlas did not flee from observation. It merely regulated it, ensuring that humanity saw it but not deeply enough to grasp its internal nature. This controlled visibility is what terrifies scientists most. It suggests not randomness, not drift, but awareness. And if not awareness, then at least routines sophisticated enough to create the illusion of self-preservation. The more data flows in, the more experts realize that every assumption about first contact might have been wrong. Perhaps extraterrestrial intelligence does not arrive with grand signals or descending craft, but with a quiet, test-stand object designed to observe and evaluate without drawing attention to itself. A machine that measures a civilization's capability by watching how it reacts to the unexplainable. A probe that has crossed interstellar space for eons, surviving cosmic radiation, starborn storms, and the slow decay of time with only mission persistence left. Maybe its creators died long ago. Maybe they live still in some distant star system. Maybe Atlas is just one of millions of devices roaming the galaxy, cataloging worlds and waiting for the right conditions to activate. As the global countdown continues, millions of eyes will lift toward the sky on December 19th, searching for answers in a point of blue light that refuses to reveal its origin. If Atlas is natural, then our understanding of nature must evolve. If Atlas is artificial, then humanity is no longer alone in the universe. And if Atlas is something in between, something ancient, autonomous, and endlessly patient, then we may be witnessing not an arrival, but the continuation of a story that began long before Earth ever existed. Whatever the truth may be, one thing is certain. 3I Atlas has forced us to confront the limits of our knowledge, the fragility of our certainty, and the possibility that the universe communicates not through words but through mysteries that dare us to look deeper. And as its blue glow drifts across the sky, silent and unyielding, the world waits not for an explanation, but for the moment when the universe finally decides we are ready to understand.